Well, hi, thanks for joining me here today. It's March 24th. I did not post a video yesterday, but boy was I in here going crazy with tube testers. I'm gonna go a little crazy again here, but just a little crazy. What happened to me yesterday was I decided I would test the tubes in this radio, which I did. And I decided I would use this tube tester. This tube tester I reconditioned about a year ago, and I haven't used it. And I thought, oh, it might be fun to bring this one out and use it. You know, I'm not as experienced or familiar with it as my other tube testers. I thought, oh, you know, who's rushing around now? We're stuck in our homes for maybe months. No need to rush around, so why not make it complicated? So, yes, I did. I use this great tube tester. The cool thing about this one is it measures filament current. I don't have another tube tester that does that. And since this is a series radio here, it might be of interest just to test the tubes and see if any of them have a funny filament current with them. They're all supposed to be 150 milliamps. They're all really close to 150 milliamps, so that turned out not to be an issue at all. No surprise in that, I think. What was a surprise was the testing I did here just didn't seem to make sense for one or two of the tubes, and so I got suspicious and I stuck them in this tube tester over here that I use a lot, and then I got conflicting results, so I got another tube tester out here. I had three of them out. A long time had gone by, and I started realizing some little tiny things about some of my tube testers. One of them, this one, when you move this to 0, yeah, it says 50 there, but in fact this control is backwards now. You move it to 0, there's a point at which it disconnects and the readings are no longer valid while it's sitting here, and I didn't know that. A bunch of stuff. Anyway, I had to retest the tubes again and again and again, getting more and more confused all the time. The bottom line is I think this one, which came out of the radio, 12SG7, is weak. And I have one other replacement which is in the radio right now, and the radio's working okay. It's working okay with this too. So I want to retest this because what a bunged up day yesterday. So no video yesterday, and we'll see what happens as I launch into another, hopefully one tube straightforward tube test. 12SG7. So let's now, I'm not going to find it on roll chart because the roll chart doesn't roll all the way to reveal the 12s. I have a copy of the roll chart on my computer over here, or so I did yesterday. Do I still have it? Do I still have it here? Is it sitting right here? Well, I've got to stop for a minute here. Okay, so you can see I've got the roll chart at the top of the screen there. You can see 12SG7, so that's what we're going to set up for here. 12SG7, so 12.6 volts on the filament. BGGG dash, so BGGG, this doesn't matter. And the next one is 26212, 26 2 1 2, and then 35400, 35400. Okay, so we should be able to plug the tube in at this point. Actually, I'm going to turn this to this open spot. There'll be no power to the heater, so in fact the tube is just sitting cold in the socket. So we'll go through the short test. On this tube, we can expect the shorts to light 2, 3, 5, and 7. Okay, going in the reverse order: 10, 9, 8, 7, 5, 3, 2, perfect. Okay, we'll put this in the test position, and now there's current flowing in the element, in the heating element. We can read the current on the meter. If I just do that, and then do that. So 150 milliamps is straight up on this meter now. So just a little over 150 flowing in this tube. I don't recall that being that high. This is higher than any other reading I took. So what we'll do is we'll check the line. We'll do the line test. Oh, I haven't set the bias on here. That shouldn't matter though. Okay, line test. So we're should be straight up. We're just about there. I can't imagine that as having any bearing on anything. Back to this. So this tube is drawing over 150 milliamps. All the other tubes that I did, I recorded all this, were right close to 150 milliamps. This one's actually a little high. Kind of, don't know what to make of that, but this is supposedly a dead tube anyway. We're going to find out in a moment. So we're ready now to do the test. Put this to test switch. This is on test. So this is the actual test on-off switch, and we're looking for an amount of 2550. So 2550 on this meter. The scale we're on is the 20, so it's the top numbered scale here, and 2550 is quite low on it. It's going to be somewhere in this area here. There we go. There we are. So it's failing this test. Now what got me off into all kinds of directions was I decided this reading is so low here that you know, it's on a low fringe of the meter. You know, sometimes you can't really trust such a low reading. So usually too they make tube testers so the reading shows up roughly mid-scale, but not with this one. They weren't able to do that, I guess. So the fact of the matter is I felt unsure because I don't like to reject tubes. Right? I don't look at a tube test and go, it's bad, throw it away. I think, well, maybe it's still good and the test has gone sour somehow. So I put that in other tube testers and everything went downhill from there as the mistakes ensued and the conflicting results came out. So anyway, I won't go into that. So clearly this is a weak tube. If you trust this tester, and my experience with all these testers is they are actually quite reliable. So there we go. So I put the replacement in. The replacement was okay. We won't bother testing that. I just wanted to make sure the one I took out was really bad. Okay, tester away. Now the next thing we're going to do, what I would normally do at this point is play the radio. But I was in here last night when I thought the shortwave stations were strong, and I was messing around with it in here, so I got a good feel for its reception. And I'll describe it because it's worth describing. Curious way this radio receives. First of all, like on shortwave, the noise level is extremely low. The radio is very, very quiet. It makes you think it's not even hooked up to an antenna or something like that. Very quiet. You turn up the volume enough to get a bit of a hiss to reassure you that you actually have the radio working. Then as you tune across, when you encounter a station, it just seems to come out of silence. Whoosh, and there it is, a shortwave station. I've read other people's descriptions of this radio, and they say things like very quiet operation and stuff like that. To me, what it seems like is the AVC is weak or has been designed in such a way that it doesn't lift the noise that's there when there's no signal. Lift it right up and shove it in your ears, like most radios do that. The AVC cranks up the radio, and then you just hear that this quiet noise is now a roar coming out of your speaker as you go between stations. That's a terrible way to listen to a communications receiver. The best way, what I do is I turn off the AVC on the radios that I have that I can do that with, and then you run the RF level at the front of the radio manually with a control. And generally when you do that, you turn the audio right up and you try to control everything with just the RF control. And the result of that is an experience very similar to this radio. We have very low levels of hiss and noise, and when you encounter a strong station, it's very, very loud. And then back again to this very low quiet. It's a very pleasant way to listen to a radio. That's how this guy works. At least that's how he works now. And exactly why, I don't know. Hats off to the designers, or were they just lucky, or is this a fluke, or is this really the way it's supposed to work? It's so different from other radios. So I think maybe the next stage with this is to go through the alignment at this point. Capacitors are changed out, the tubes have been checked, one has been replaced, the rest have been verified as functional, and the radio has gone through a regular test last night. So yeah, so I think alignment is what's next. Unfortunately, I just made a video error and had you looking at one thing while I'm talking about something else. So I'm going to kind of just go over what it was I have concluded here in studying this. So you can see in this schematic, the feedback is from the output of this SG tube back to the input through these capacitors. I can't find any of this, any of these connections. It's not the same in this radio at all. In this radio, they take the output, and I think it's hooked up in this area here, and try to fire it all the way back to this tube. To this transformer. So they're trying to pick the signal off literally on this wire right here. They've wrapped this wire around the wire that runs through the back of the radio. So to pick up signal and convey it all the way into here by just having the wire run through the terminals of this transformer. So if you can get enough signal out of here onto this wire, maybe this would work. And the objective here, and I hope I'm not repeating myself now because of my video mistake, the objective here is to make the IF oscillate at its tuned frequency of 455. So it's when you throw the CW switch, this starts oscillating quietly. You wouldn't hear it in the speaker. There's no modulation in it. It's just an RF signal in here. You'd see it on the AVC voltage, I would think. Oh, what a crazy thing to do! You get this thing oscillating in here, it's going to cause the AVC voltage, it's going to quiet down the radio just from its own oscillation. What a precarious thing. So then you tune in another signal, and you slowly, as you tune it, you bring it to 455. Just before you get right on 455, let's say you're at 454, there would be two signals in here. The oscillating 455 and the converted 454, there's 1,000 hertz between them. So somewhere in here a difference frequency is resolved, and where exactly does that happen? I mean, you need a mixer tube or some tube operating non-linearly. Maybe this does it. Maybe the diodes are enough to cause the two signals to mix and resolve a difference frequency. I don't know. So I did a little experimenting here. Maybe that's on video, I'm not sure. I couldn't get any kind of action whatever. Fooling with the switch, fooling with the wire. Nothing at all apparently happening. No oscillation in here. So then I asked myself, is this even worth making it operate? What do you need a BFO for? In a radio like this, you would use it to provide a tone on CW, on Morse code, and some other single sideband signals, and you'd also use it to clarify voices in single sideband. This has got to be the lousiest BFO arrangement you've ever seen. How well could it ever work, even if it did work? I think it's just an excuse to claim the radio has a BFO function, and they kind of whipped it in this really crummy way, rather than have another tube and another oscillator, which is really the better way to do it. Cheap, and what do I want to listen to Morse code on this radio? I don't. This will be a broadcast receiver. I won't even use this feature. So based on all that, that's the end of the investigation into this. For now, maybe I'll come back at it. Maybe it'll start going. I don't think so. I think it's a dead dog. I think it's a sad attempt at putting a BFO feature into this radio, and I think it's the marketing department said, if you can just stick a BFO on it, we're going to sell another 100 radios. It's worth it. Okay. Okay, now this is a preliminary alignment I'm going through the first time. I always consider it to be preliminary. I expect I'll be doing it again towards the very end of this whole thing. So next step along the way, it's up on the screen there. BFO adjustment is what this is titled. Same as step 1. So that's the connection where I have it. Oh, yeah. 455, no modulation. Okay, so I'm going to turn off the modulation. Okay, sorry, no adjustment I had to make there on the signal generator. Radio set to 1 megacycle. That's just roughly, I think, the middle of the band, I think is what they're really saying there. Didn't do this before, but I'll do it now. Okay. I don't think it's that critical. Set AM CW switch at CW. So AM CW switch. Okay, set to CW. Reset the switch to AM. Yeah, Jim, don't forget. That's what this note was written specifically for me. For correct BFO operation, vary the coupling between lead E and pins 4 and 8 of the 12 SG7 for maximum beat note. So we're throwing in a 455 kilocycle unmodulated signal, and we should hear a beat with it. Maximum beat note. What do they mean by that? They mean maximum volume or maximum pitch? Must be volume. Push lead E, oh my gosh, towards pin 4. Pushing lead E towards pin 4 increases the strength of the beat. Pushing. Vary the coupling between lead E and pins 4 and 8 of the 12 SG7. Oh my gosh, I wish I'd read this earlier. Is that how critical this set is wired? Oh my gosh. So 12 SG7, pins 4 and 8, lead E. Oh my gosh, is this marked out somewhere? I don't think so. There's no diagram of that in here, is there? This wouldn't even help. There's the BFO. There it is. V2. You know, the wire in my radio doesn't run like this. It doesn't run like that. I'm looking at it. This is done differently. My radio's done differently. It's not done like this. So the lead comes back. It doesn't go into this tube socket at all. It gets wound past one of the IF transformers here. BFO wire lead. That's definitely what that is. I think we're on our own with this. That looks like it's connected right in there, but I think it's not. I think they're just moving it around. Well, man, that leaves me in a quandary. Is there another diagram for a different radio? I don't think so. Okay, let's take a close look at what they're trying to do here. So what are they trying to do in this radio? So we got the switch here. BFO wire lead. I think this is just a notation. This is not a thing in the radio. So the wire just comes all by itself through here. It gets wound around the pins on this tube. It's going up here to a switch where it's going somewhere from here. This is quite an oddball thing. It's got to be an afterthought. So here it is shown schematically. So I believe now the way to interpret this, these dots here, is that this is the point at which the wire... I know this doesn't add up at all, because the wire I'm interested in, one end goes to a switch, and the other end just ends in space. It doesn't connect to anything. And in the diagram it shows it running through the pins of one of these tubes, one of them. But my wire runs through the pins of one of these IF cans. So what are they really trying to do here? They're trying to get the IF to oscillate on its own at 455. And then when you bring in the signal you're interested in, if it's not completely tuned perfectly, then you're going to get a difference frequency. So let's say you've tuned in using the local oscillator a signal, and instead of creating 455 with it, you're creating 454. Pushing that through here. Would it go through? You'd hear 454. But in here is a silent 455 oscillating because of this feedback wire. Yeah, look at that feedback wire, right from the output right to the input, with a killer in the middle to kill it. So you get this tube oscillating. It's oscillating. You know, it's not really like oscillating through coils. So I'm not sure. But in any case, you get it oscillating at the tuned frequency of the IF, 455, all by itself. Along comes the 454. There's a difference frequency, but it's here. It's not back here in the mixer. So you can see, yeah. Normally you have only one kind of signal passing through the IF, the converted signal you're interested in. But I have had radios that do oscillate in the IF, and as you tune through, you hear a whistle. A couple radios ago, this was quite distinct in one. And that whistle is the oscillation of the IF itself. So, and then you have the difference frequency of the thing you're tuning in as you bring it closer and closer to the 455. So this radio is making use of a problem that occurs in these radios, accidental development of feedback. This guy is trying to do it under control. So in my radio, these capacitors, they don't look like this. They don't sit like this in the wire. They are pieces of metal. Now we got to look at this piece of wire. There's more going on in this radio than what is shown here in the schematic. Oh my gosh, let's go look at it. I just have the feeling I'm on my way to a long session here today. The problem with that in doing my videos like you watch is if I do 4 hours of video in here, you know, I am not going to be able to make a 1 hour video out of it that makes any sense to anybody unless I spend days on it. And I don't want to spend days on video. I want to spend days working on this stuff. The videos are rather secondary to it. Okay, let's examine this thing. Here is the wire, this heavily insulated wire. Reaches a terminal strip and then goes to the switch back here, which is the CW switch, which I'm going to put back to AM. This wire runs along pretty straight, pretty bold. At this point, the wire is partially wrapped by another wire. So this is a Gimmick. It's on the output of the second IF. Yeah, on the second IF. So the powerful output on this green wire here. A little bit of it gets onto this guy, this thing. If it goes this way, well, it encounters the switch, which is doing something I don't know what it's doing yet. We gotta assume the schematic is just way off. It doesn't reflect this at all. And then down we come, the other end of it. So, you know what it's doing? It's quite simple. I can see it quite clearly. It's taking the strong output on the green wire here, putting a little bit of that into this heavy feedback wire. The heavy feedback wire is then installed very close to the first IF, right through here. So some of what's coming out here is sent back to the start to come through this amplifier again. Out here, there's a ground, I don't know what to call it, I guess a ground strap, or what would be a gimmicky capacitor. It's really hard to see. You can actually see it there. I'm pointing right at it. That's just a little piece of metal that's brought up and wrapped around the wire, and the wire ends just out of sight. It ends right here. You can kind of see that it ends. It just ends. So the idea, I think, if you unground this wire, then it'll convey the feedback, and if you apply a ground to it, it'll shut it off. What a weird arrangement. Now, I haven't heard the CW work. I haven't really tried. We're going to try it and see if it works. CW, BFO, BFO. That's really what I want to say there. And I was going to hook up this nice thing to the speakers. We still have our signal generator connection. Oh, that's right. I had to give time for these tubes to cool off. That's so, you know, it's not obvious to you as you watch my videos, but I'm living my life here at the same time. I'm stopping the work and going out in the house and doing other things and coming back in, spending some time with my wife and eating lunch, watching TV, and then coming back in. You don't realize what has happened to me when I disappear, and that's a good explanation for why sometimes I come back. I can't remember what the heck I was doing, and it's probably apparent, and it looks weird in the video, because in the video, you know, a few seconds have gone by, and suddenly, what's he doing now? What happened? It's because I was away for 10 minutes. There we go. And that's all it takes. Okay, so now how would we know if this is working? Because we've tuned in a signal, and there's this annoying whine with it. So we're up around 1,000,000. I'll set the signal generator to 1,000,000, but we don't want it fed. We don't want this anymore. We don't want this on here anymore. Put this off. Okay, we're going to feed the signal into the antenna. Hey, what an odd thing to do. I'm going to leave this on the B-. Maybe that's really not the best thing to do, but I'm going to do that. Let's stick a capacitor in here because I'm a scaredy cat. Increase the apparent impedance of the signal generator from the radio's point of view. Okay, so we want this up around 1,000,000. Something like that. The signal strength is appropriate. Switch on the radio and see how it goes. Put in the missing tubes. That was troubleshooting. Isn't that amazing? Took me 1 second to realize what was wrong with the radio. Impressive, Jim. Okay, let's see if it'll work this time. 105, that's right on the money. 105 means it's drawing current through the dim bulb. We should hear something. You want to be on band 1 to hear this. Band 1 is a broadcast band. Just a big honkin' hum. Okay, so the antenna input is basically shorted by the signal generator. So unless the signal generator is hitting the mark, we'll hear nothing out of this radio. I turn it down because I have it up pretty high. We're back in the isolation transformer again. Okay, radio, this is your chance to show off. Turn it up. I have no modulation. Let's put the modulation on. Oh my. Yeah, the signal's definitely there. Cut it back. cut it back. Cut it back a little too far. Good responsive meter now. Why did, oh yeah, we're gonna do the BFO thing. Okay. Oh. Hey, look, I'm overloaded. I'm overloaded here like everybody with what's going on in the world. So, you know, every 3 or 4 seconds my head is flipping back to what is happening around us here. So I'm trying to not let that happen, but wow. It's hard. It's very hard. It's hard for all of us. Where's the BFO sound? We need to turn on the BFO. Okay, assume that's on now. So what we would expect, because we have a signal going through the IF properly, and we should have this oscillation going through there too, causing a tone. As we tune the radio, we move the target frequency, the thing we're listening to, back and forth, but the oscillation remains the same. So you move the signal back and forth. Woo, woo, woo. We should hear that if we tune something in. And we have this tuned in. We don't hear anything. It would appear to be quite clearly not working. So from what little I read on the internet about this, people were not at all impressed with this function in this radio. And I think I can see why. How can we get this guy to oscillate? Make sure the switch is working first. Is there any moment where the set oscillates? Pretty dirty switch. No hint of any kind of oscillation. So we can poke around with that wire a little bit and see if one starts. The instructions in the manual were move something towards something. Those instructions are useless in this radio. So I'm going to grab onto that big honking wire and just see what happens. Try not to short anything. So why wouldn't it oscillate? So it wouldn't oscillate because there just isn't enough feedback to make it work. The strong signal is here and the weak stuff is happening down here. This is the area that would be failing, I would think. There's just no hint that this is going to work. I think I need to figure out what is going on with the switch up at the end here. I don't think it matches the schematic at all. Let's look at the schematic here. I think I can get it on the little window there. So what we want to look at is right here. So this is the switch that's currently set to CW. First it goes through a resistor, a 470 resistor. I think I saw that in there. Right there. That's probably it. And that resistor goes over to the standby switch. Is that what that is? Is that really a standby switch? Receive And what's the other word? Stand by. Okay, so that's a switch that's, if I remember right, opens the cathode on the IF tube and shuts everybody up. Isn't that odd? So there's a resistor. So I think what that was the I probably moved the little tab on the switch, and it probably actually moved the switch inside a bit. Yeah, how do I know this switch is really making any kind of contact? So that's a 3-position switch. The one in the schematic is a 3. Yeah, it's a 3-pronger. Yeah, and the one there, the center one would go to B minus. So this is the center one here. It's going to go to a B minus point. Oh my gosh. I'll have to... Is that really B minus? And then off that, looking at the schematic, yeah, the resistor is in one of the switch legs on the CW leg. So this wire from the feedback wire is connecting to one of the outside terminals. So if they soldered the other 2 terminals together, no, I don't think so. Doesn't look like it. No, there's no wire between those. So they're switching the center terminal to this wire or to this wire. This wire, the back one, goes to the funny guy that runs through the radio. Other wire. So the one they're switching back and forth. What is that? So generally, you have a switch that's going to pick one pole or the other. It's the one in the middle that is the thing that's being switched. That would be this wire. This wire comes down and hooks up to one of the terminals on this tube. Wow, is that ever hard to see? Sorry about the lighting, but... So, yeah. Okay, this terminal. Hey, let's figure out what that is. That's terminal 1, 2, 3. So it connects to terminal 3, pin 3 on the SQ tube. Pin 3 on the SQ tube. Okay, so SQ is over here, and pin 3 is this. That's entirely different from this. I noticed this before, earlier, and I just sort of wrote it off as, you're not understanding it right, Jim. Don't sweat over it. By the way, while I'm doing this work, and I think everybody does this, and you're coming up with observations and stuff like that, I'm weighing them as to how important they are at the same time. If I weigh its importance as very low, I don't even care if the observation's true. It doesn't matter. That's what low means. If what I'm looking at, in my mind, becomes something more critical, then I'll pay more attention to it, and I'm more likely to be correct in what I'm saying. So just, keep your thinking cap on when you're listening to me. Just spew out stuff as I look at this. I'm not reading a script here. Maybe I should start reading a script. Can't script this stuff, really. Oh my gosh. So another question is, how important is this BFO thing anyway? The importance is nil. So I think I'm going to walk away from it at this point. Maybe it'll come up again later in the scheme of things, but really, you need the BFO to put a tone in to Morse code and some other single sideband transmissions to clear up somebody's voice in sideband. I'm not going to be doing that with this radio. I got a ham radio for doing stuff like that. So regardless of how this is really supposed to work, I'm just going to give up on it for now, anyway. Okay, so having given up on that, what's left? We would go back to doing alignment work, and we would finish off the front end alignment. So I think the last thing I'm going to do with this radio today is play it on the antenna and see where we're at. Nothing much happened here today in tuning up the IF. I'm sure it made minimal difference, if any difference at all. And I'm going to want to put the antenna on it. Chassis. Okay. Let's see what it'll do at 11 o'clock in the morning here. We'll go to band number 1. Everything normal. Oh my gosh, that's just terrible. I'll bet you the antenna's not switched on here again because I was listening to shortwave last night again. Now, so I'm going to go through the switch. So that static you're hearing, yes, I am trying to resolve where it's coming from. I'm not having any luck with it so far. Let's try another band. So that was the AM band, pretty poor. Okay, we might get something up in this range on this band. Oh, listen to that. How do we end up with that? That's kind of interesting. So this is with CW on, and that's with CW off. When you turn that off, that wire running through the back there, I think it's just an open piece of metal, unbonded back to the chassis or anything. So it may not be feeding back the way it's supposed to, but it may be feeding crap inside this radio. I should rip that thing right out of there. Just get it out. Get the whole wire out of there. And abandon this useless function. So what happens if you got something tuned in here? If you can. Wow, this is just really going south. What happened? Did the antenna come off? I was working a little better a moment ago. Oh, no, I'd have to switch up. Is it my imagination or this thing just... it likes the noises. I think this thing just went downhill. Oh, I changed. You dummy, I'm up on the shortwave band. I'll be okay eventually. So, look at that. Okay, aside from this hum, which we're going to try to get rid of, that station came out of silence.
Just called the Holy of Holies. Verse 4, having a golden altar of incense and the Ark of the Covenant, covered on all sides with gold, in which...
CW. There is some kind of effect there. This doesn't work quite the way I think it does, too. I have to find some ham radio stuff. So this time of day, way up here. We gotta get rid of that hum, that's for sure. Same signal in two places, roughly a megahertz apart. Band 1, AM radio.
Specifically target hydro.
Hydro race for the next 45 days. The announcement is being made by Premier Doug Ford and Energy Minister Greg Rickford later today. A government source told the Globe and Mail. The current off-peak overnight and weekend charges will take effect today, saving families about $20 a month, small businesses up to $150, and farms more than $300.
So what's happened in Canada is the governments at all levels are looking for fast ways to shove money into the population's hands. And so there's a number of fast things that can be done where the government stops taking money from you. In my province, the power system is a public company. So they're just ordering the public company to drop its rates. That's basically what I heard. I think they're going to run on overnight rates, which is about half the regular rate during the day. So that's what's happening here. We're kind of done here. So, I live in Canada. You probably don't if you're watching this video, and there's a good chance you live in the United States, but you could live in Britain and anywhere else in the world and watch my videos. I do have viewers all around the world, and everybody's wondering what's going on. In Canada, our governments are operating in a highly coordinated fashion. In fact, it's totally impressed me. The opposition has stopped being a opposition, just a general opposition. They're now being very careful about what they are critical of. They have told all of us Canadians, the opposition parties, that they are going to play along with the government. They're going to keep an eye on what it's doing, but the government is trying to move as fast as possible to implement anything it can do to flush money out. I'm sure this is happening in other countries too. The thing is, in this country, in my country, the politicians have decided that, look, we are all in the same boat at this point. Let's not be fractious or political about everything. Let's just try to do the right stuff. So my hat's off to all the politicians in Canada who are usually fighting. It looks like the fight has stopped for our sakes right now. So that's what it looks like now. we'll see, because the real ugliness of this whole thing hasn't come yet. And when it does, the pressures and strains on everything and everyone is going to be very high for some number of weeks or a month or two. Who knows what's going to happen? At this point in my country anyway, the political system is pulling together and decisions are being made very, very appropriately. So I'm very lucky to be in Canada. We are kind of ready for this, as ready as you can be for something like this. So maybe I'll say a little more. In my own city, I live in a city of 30,000 people. I live about an hour and a half drive from the huge city of Toronto. The city of Toronto is a 3.5 million people in it. Near me is another city, kind of between me and Toronto, but closer to Aurelia, called Barrie. Barrie has about 130,000 people in it. It's a fair-sized city. Barrie has the first cases and the first deaths of, maybe not the first cases, but the first deaths in my province were in Barrie, a 10-minute drive from here. So that's a little close to home. In my own community now, we've received instructions on what to do if we're feeling sick or we think we need some kind of medical attention. We call up the health authorities in our area. We state our situation. They give us directions at that point over the phone. The direction could be, you might have COVID. Are you well enough? Can you drive your car? Would you take your car and drive down to a mobile testing site, which has been set up on a street adjacent to our hospital here? When you reach the mobile testing site, a person will come to your window and interview you, ask questions, take your temperature, and do whatever they can without actually spending a test on you. From that person will make a judgment as to whether you should simply be sent back home and stay there, or you need to be tested for COVID. You will then go to another location, probably a few hundred meters away, where the swab will be taken. Then you'll be instructed, go back home, but if you're really, really sick, I guess you can go into the hospital at that point, and you have already gone through some preliminary stuff. In the Canadian system, I think what the Canadian system is trying to do is going to try to move the regular patients that are in the hospital into temporary establishments, hotels and things like that around the hospital, and continue to treat them in the hotel environment, and they're going to make the hospital the COVID center, so all the facilities are there for the doctors and nurses to work on what was probably going to be hundreds of people in my small city that are going to end up wanting to go to the hospital or having to go to the hospital. So all these things are taking place or have taken place. In terms of materials, testing and that, currently Canada's fallen a little bit behind. We're able to take the swabs and stuff like that, can't test them fast enough, but moves are being made all across Canada to greatly increase, as you're hearing in all kinds of countries, to greatly increase capabilities for doing this, and I think it will happen. And then me personally and my wife, what have we decided to do? We are hunkering down in our house, as we've been told. Staying in your house in the winter is no big deal. In Canada, we do it all the time. And going out with all kinds of protection on in the winter, we do it all the time. With hats and gloves and everything to protect ourselves from the attacking cold. Well, now it's the attacking virus. It's kind of the same thing. You put on coats and gloves and stuff like that. It's kind of the same thing. So for Canadians right now, this is not a hard slug. For those of us who, like me, I'm semi-retired, right? So I don't have to go to work. Not very disturbing for Canadians. Not like I go to the beach every day. I don't. So that's all good stuff. At the same time, I won't go into any details about my personal circumstances or my family circumstances, but there are circumstances already for me and my family. So we're in the boat with everybody. And if you're Canadian listening to this, hey, just look hard. I'm in the same boat as you. See? Can you see me? I'm waving. I'm waving to you now. We're in the same boat. Man, are we lucky to be in this boat. I wish you all the best. I'll see you tomorrow. We're going to do the front end alignment on this radio and then assess whether there's anything more I can do with it. And, we're going to try to drum out that hum too. That's the plan. Everybody, stay safe.